Hi, this question appeared in JEE Advanced 2015 in its paper 1, and the question is from the topic determinants, and it is a multi-correct answer question. It can have more than one correct answer. So let us go ahead and solve this question. But before we do that, I would strongly recommend each one of you to pause this video at this moment and give this question a try. So yeah, here we basically have to solve this determinant. So before going ahead and solving the determinant, I'll try to give a brief idea about this question. So whenever you find these kind of determinants, we usually, like instead of solving for the determinant just by expanding the determinant, so we go for row column operations. All right. So the usual idea, so this is a very traditional way of doing it. The usual idea is to make this term and this term 0 using row column operations, because then the determinant becomes really simple. We have to take this term and this will be the cofactor of this particular term, and we'll just get the determinant value just by some multiplication and addition. So the idea is to make this term and this term 0. Okay, so let us go ahead now. To do that, let us first apply row operation. We are applying operation on row 2, r2 minus r1, and for row 3 also, r3 minus r1. You can always do this. These are like this is a very formal way of doing it. So this is all same, 1 plus 3 alpha whole square. Now r2 minus r1, so that will be, alright, 2 plus alpha whole square minus 1 plus alpha whole square. This is in the form of a square minus b square. So you can just directly apply the formula. A plus b, that will be 3 plus 2 alpha into a minus b, that will be 1. Similarly here, a plus b, that will be 3 plus 4 alpha, and a minus b is 1. Similarly here, 3 plus 6 alpha. Now we are applying this operation on row 3. So again a plus b whole square formula. So a plus b, that will be 4 plus 2 alpha, and a minus b is 2. Here it will be 4 plus 4 alpha and multiplied by 2. Here it will be 4 plus 6 alpha multiplied by 2. Alright, this whole thing is minus 648 alpha. Okay, now we can bring out this 2 from this row and we can send it to the other side. So that will make this determinant, and there is one more 2 in all the, okay, we don't have to do that. So that will make the determinant, the right hand side will be by 2, divided by 2. All right, now again what we will do, on r3 we will apply r3 minus r2. All right, so that will be 1 plus alpha whole square, 1 plus 2 alpha whole square, 1 plus 3 alpha whole square. This is 3 plus 2 alpha, 3 plus 4 alpha, 3 plus 6 alpha. And then here when you do r3 minus r2, this will be 1, this is also 1, and this is also 1. See how simply it got reduced. So this will be 3, 2, 4 alpha. All right, now we can split the above determinant in this particular format: 1 plus alpha whole square, 1 plus 2 alpha whole square, 1 plus 3 alpha whole square, and the third row is 1, 1, 1. Second row can be split like this: 3, 3, 3, and again similarly here we'll get 1 plus alpha whole square, 1 plus 2 alpha whole square, 1 plus 3 alpha whole square, 2 alpha, 4 alpha, 6 alpha, 1, 1, 1. Right, we can split that determinant into 2 parts. Now if you check this, if you can take 3 common from this row. So if you bring out 3, this row will be 1, 1 and 1. So 2 rows are same. So this determinant value will be 0. Now you don't have to worry about it. Let us go to this determinant. So if you check the second row, 2 alpha is common here. Alright. So that is 1 plus alpha whole square, 1 plus 2 alpha whole square, 1 plus 3 alpha whole square. And this will be 1, 2, 3, 1, 1, 1. And 2 alpha is common, that is minus 324 alpha. Okay, now what was the idea? That you can make any two terms 0 actually. See, so those two terms doesn't have to be these two. Okay, any two terms in any single row or any column, you can make them 0. So what we will do, we will apply for column 2 C2 minus C1 and for column 3 C3 minus C1. So this will be 2 alpha. Column 1 remains same, 1 plus alpha square, 1, 1, 1. And column 2, so 2 minus 1 is 1 here, 1 minus 1 is 0. And 1 plus 2 alpha whole square, so that will be a plus b into a minus b again. So 2 plus 3 alpha into alpha. Alright, here C3 minus C1 if we do, that will be 2 plus 4 alpha times 2 alpha. And this will be 3 minus 1, that is 2. And this will be 1 minus 1, this is 0. So if you observe, we made these two terms 0. So in any row or any column, if you are able to make two terms 0, it will be very easy to evaluate the determinant. So now the value of this determinant will be 2 alpha times, so this 1 into these two things multiplication minus these two things. So that will be 2 alpha into 2 plus 3 alpha minus 2 alpha into 2 plus 4 alpha plus 324 alpha equal to 0. I just brought it to this side. So this will be 2 alpha into, this is 4 alpha plus 6 alpha square minus 4 alpha minus 8 alpha square plus 324 alpha is equal to 0. This and this gets cancelled. So that will be we can take 2 alpha common, so that will be 6 alpha square minus 8 alpha square, that is minus 2 alpha square. 2 alpha with, like, this is common in 324 alpha also, this will be plus 162 162, that's all, is equal to 0. So 2 alpha times one more 2 alpha, okay, this will be, let us bring out minus 2, this will be alpha square minus 81 is equal to 0. So either 2 alpha is equal to 0 or alpha square minus 81 is equal to 0, which implies that alpha is plus r minus 9. Okay, in the options we have plus 9 and minus 9, but what about 0? Okay, we don't have that. So these are the three values of alpha that satisfies the equation. So option B and option C are correct. So if you like the solution, give this video a like, share it with your friends and subscribe for more such content. And if you have any queries, write it up in the comment section. Thank you.